Okay, we are going to talk more on parent functions with Mrs. Fields Math. We have three parent functions already. We have the absolute value function, f of x equals the absolute value of x. We have the quadratic function, f of x equals x squared. We have the cubic function, f of x equals x cubed. Now, all of the equations you see before you, you have the parent function equation as well as its graph. You need to be able to recognize the graph and say, okay, this is a graph of a quadratic. This is a graph of an absolute value. This is a graph of a cubic. But not only that, you need to be able to tell me, okay, the parent function for the absolute value is f of x equals the absolute value of x. The parent function for a quadratic is f of x equals x squared. The parent function for cubic function is f of x equals x cubed. So not only do we have to recognize graphs, but we also have to remember the parent function equations, okay? Now, how I do on the identifying the graphs is I think of the absolute value as a V, okay? A nice, pretty, pointed V. Anytime you see a V, it's going to be an absolute value function. A quadratic function is a nice, smooth U, okay? A cubic function is an elongated or stretch out S. And, you know, on the cubic function, that's kind of, it's a stretch, but thinking about an elongated, stretched out S, maybe, you know, it's kind of stretched out in the middle there, that gives us an idea of what the graph looks like, okay? Now, we have general forms of all these equations. Our first one is the general form of our absolute value function, okay? F of x equals a times the absolute value of x minus h plus k. Then we have our general form of our quadratic, f of x equals x squared plus, general form, f of x equals a times x minus h squared plus k. That is our quadratic function. And last but not least, we have f of x equals a times x minus h cubed plus k. That is our cubic function, okay? And, you know, we have to know these. We have to recognize these. We have to be able to write these. Okay, you might ask me, okay, what good is general form at all? Well, okay, we're getting ready to talk about what good it is. We have our absolute value, our quadratic, and our cubic. Notice in all of them, we have an a value. The a value is located out front of each and every one of these, okay? A is noted as our leading coefficient. Now, if a has a value that's equal to 1, we would never mention any type of change, okay? If a has a value, and I said it, but I didn't write it down, I'm sorry. So if a equals 1, we have no change from a parent function, we wouldn't even mention it. If a is between 0 and 1, a fraction or decimal, not an improper fraction. An improper fraction has a value greater than 1. It has to be between 0 and 1. We're not talking negatives either. Then we have a vertical compression, and that means we have a shrink. That means our output values, our function values, our y values are smaller than that of our parent function, okay? If we have a that's greater than 1, we have a vertical expansion, a vertical stretch. Our output values, our function values, our y values are now greater than the y values of our parent function, okay? Now, that's noticing that a is in all of these. Well, do we notice anything else that's also in all of those general forms? Well, I noticed the very next thing they have in common, other than the x, is the h. There's an h located in every one of those equations. And notice the h is grouped with x, okay? In each one of those functions, that h is grouped with x. H is going to determine our horizontal move, okay? Now, the subtraction sign means if we see a function that has absolute value of x minus 5, or if we have x minus 5 quantity squared, or if we have x minus 5 quantity cubed, okay, something is grouped with x, okay, and we see x minus that number. H would have the value of a positive 5. So if we wanted to know what the value of H was, we would say H equals 5. That determines our horizontal shift. Since 5 is a positive 5, it would be a horizontal shift right 5 units. Okay? Now, also keep in mind, if we see a function that we notice we have the absolute value of x plus 5, or we have the absolute value of x plus 5 squared, or we have, I'm sorry, not the absolute value. If we have let me just start that whole thing over. If we see a function that has the absolute value of x plus 5, or we have grouped together x plus 5 squared, or grouped together x plus 5 cubed, we don't see a minus. So that means that our value of h would have to be a minus 5 or a negative 5. That means we would have a horizontal shift left 5 units, because a negative 5 means I go left 5 units, okay? But you might say, okay, why do we get a negative 5 when we see plus 5? Well, the reason why we have a negative 5 when we see x plus 5 is because in order to see plus 5, we have to have x minus a negative 5. When we have subtraction, we add the opposite. So x minus 5 becomes x plus, or x minus a negative 5 becomes x plus 5. So the h value would be a negative 5. And again, I would have a horizontal shift left 5 units. But that's not all that all of these have in common, okay? We still have all three of these. We talked about our A value, which determines our vertical expansion or compression. Our output values get larger or smaller. We talked about our H value, okay? If our H value is positive, we go that many units to the right. If we have an H value that's negative, we go that many units to the left, okay? So if I have an H value of 3, I would say I have a horizontal shift right 3 units. If I have an H value of a negative 3, I would say I have a horizontal shift left 3 units. But we also have a K value in all of these. That K value is also the same, okay? But the cool thing about the K value is tacked on the back. It is our vertical shift. I'm either going to go up or down if I have one. The vertical shift is exactly as it appears. If we see a function that has, for example, f of x equals the absolute value of x minus 5 plus 7. I have no vertical expansion or compression. My A value is 1. My H value is a positive 5. I would go right 5 units, a horizontal shift right 5 units, okay? But this plus 7 is exactly what it looks like. I have a vertical shift up 7 units, okay? That is what is so cool. It doesn't matter if I go up 7 units. It also doesn't matter if I see something and I'm going to go down 7 units. That minus 7's tacked on the back, I'm going to go down 7 units. That's what's so cool about it, okay? We've talked about our 3 parent functions already. We're just getting these over and over again. Our absolute value, our quadratic, and our cubic. We have to know what the graphs look like. We have to know that every absolute value is a V. Every quadratic is a U. Every cubic is going to have a little funky looking S, okay? Elongated S. We have to know their equations. Make note of the shape and the parent equation for each one of these. We have to know them, okay? Now, what we're going to do now is we're going to add 2 more. We're going to add our square root function, and we're going to add our cubed root function. Notice our square root function, and I kind of describe it as a partial check mark, okay? So I have a starting point, and I go off in one direction, okay? We have f of x equals the square root of x. In our cubed root function, we have a sideways looking s, okay? That sideways looking s, you know, it's stretching for our imagination, but it does give us an idea of what the graph looks like. And we have to know these. We have to identify them and categorize them. Okay? The beautiful part of general form, I love it. And if you'll notice, both in the square root and the cubed root function, we have our A value, our H value, and our K value, and they stand for the exact same thing, okay? Excuse me, I went a quick, but you can back up and you can pause it. It's great. You might say, okay, what's the deal? Well, of course, I'm a nerd. I love it. I love how all this works together. The beautiful part about it, I just got our new square root function, our new cubed root function, and all of these, it still means the same thing because it doesn't matter what parent function I get, except our linear. We'll talk about those later. Okay. In all of our parent functions, except linear functions, our a value will always be our expansion, our vertical. I don't have vertical in there. I forgot to type that in there. So you need to be sure you put vertical expansion or compression, stretch or shrink. Our h value will always be a horizontal shift. We will always, if we have an h value, we'll say we moved 3 units to the left or 3 units through the right, or, whatever we need to say, okay? Our h value will always be opposite of what we actually see on the equation. Our k value will always be tacked on the back. It's always going to be exactly what we see. So, and I think that's so cool because I don't have to learn anything new. Okay? Now, we're going to jump into classifying the graphs real quick. Again, we have to know the shapes of the graphs, okay? The shapes of the graph will identify all of the families. A V shape opens up or down. Whether or not it's fat or skinny isn't relevant. It's always going to be an absolute value function every single time. We'll have a U shape, okay? Our U shape, it'll either open up or down. Again, it doesn't matter if it's fat or skinny. Each time, every time, all the time, that U shape is going to be a quadratic function family every single time. That's what's so cool. Now, we get our last one, which is the S shape. It's vertical. It goes up and down. Our S, it's a shape. It goes up and down. It's kind of stretched out. Each time, every time, all the time, it's going to be a cubic function family every single time. We also have our cubed root function family. We have that one. And instead of the S being long up and down, the S is going to go sideways. It's kind of laying on its side. And again, that's a stretch, but it does kind of give us an idea of what the graph is supposed to look like. Now, we have one more that we need to get, and that is it's our check mark shape. It has a starting point. It continues off in one direction, and that is our square root function family. Our square root function family. So that is what's so cool about that. All right. Now, next thing that we're going to try this again on the classifying our graphs. The first graph that we get is a U shape. It's smooth. I don't care that it opened down. Not at all. It's the quadratic function. I don't care if it opens down. I don't care if it's open up. I don't care if it's fat. I don't care if it's skinny. It's a U. It's smooth. It's a quadratic. Okay? The next one that we get, let's look at it. Okay? This is an S. It's a vertical shape. I'm top and bottom. It's up and down. So the up and down is a cubic function family. That's f of x equals x cubed. Each time, every time, all the time. That's what that is going to be. Let's look and see what our next one is. Okay. Ooh, that's a V. That's pointed. A V shape, nice and pointed. That is going to be our absolute value function. Okay. So every single time, doesn't matter if it opens up, opens down, doesn't matter, fat, skinny, anytime I see a V, that's going to be an absolute value function family, okay? The next one that we get, let's look at that one. Ooh, okay, I have a starting point, and I'm going off in one direction. That's going to be a square root function. That's a partial check mark. I kind of go here and then go off in one direction. The square root function family, okay? Our last one that we get to identify, this one right here, is kind of sideways. It's a sideways looking S. It looks kind of weird. We don't care. That each time, every time, all the time, I'm going off to the left or right. Now, a cubic function goes up and down, if you remember. Okay? It's topping out the S. The cubed root function is sideways. Okay? My S is going off to the left and right. I'm just kind of stretched out. Okay? Now, describing transformations is all the same. When you're describing and you're working with general form, It's all the same. We don't have to learn anything new. So one more time, we're going to hit it. Okay. The beautiful part, the beauty of it. Okay. And these parent functions, okay, again, all except for our linear functions. Okay. Our A, our H, and our K, they all represent the same thing. An A value will always be an expansion or compression. Okay. Now, a parent function, the A value is always 1. Okay. It's never seen. It's always understood. Okay. Our H value will always be our horizontal shift. If we have something grouped with X, what we see, H will have the opposite value. So if we see X plus 3, our H value is minus 3. If we see X minus 7, then our H value is a positive 7. Okay. But that's always going to be our horizontal shift. So if we're seeing X plus 3, H is negative 3, so I would state I have a horizontal shift left 3 units. Okay. If I see X minus 3, then my H is a positive 3. And so I would, on my describing my transformations, I would say I have a horizontal shift right 3 units. All right. Last but not least, our K value will always be the vertical shift exactly how it seems. I'll either go up or I'll go down. So if I see plus 7 tacked on the back, then I'm going to have a vertical shift up 7 units. If I see minus 12 tacked on the back, then that minus 12 tells me I'm going to have a vertical shift down 12 units. I appreciate your time. Be sure and do your practices.